Hey guys, in this video the lovely Mr. B is going to be working through a set of questions on binomials, starting with nice-ish easy questions and working through to some tricky ones at the end. You can look at the pinned comment for the timestamps of those. Now you can jump into this video and start wherever you want to. Start with the medium questions, easy questions or the hard questions, and then go backwards and forwards as it suits you. If you want a load more questions to practice, then they're all waiting for you over my website.
We are going to have a look at binomial expansion, and the first binomial we're going to expand is a third minus x, and all of that is to the power of 4. Now, before we answer that, let's have a look at what binomials mean. And so I'm going to expand some simpler binomials. So the first one we'll look at is a plus b to the power of 2. So to do a plus b to the power of 2, that means we have a plus b, and the power 2 means that we have 2 brackets. And so we want to expand with double brackets. So we want to do a times a, which is a squared. We want to do a times b, which will give us ab. We want to do b times a, which will give us ab. And we want to do b times b, which will give us b squared. Now, collecting those terms together, that's going to give us a final answer of a squared plus 2 lots of ab plus b squared. And what I'm going to do here is, you don't normally do this, but I'm going to write 1a squared and 1b squared for that. So we've expanded a plus b squared. Now the next one we're going to look at is a plus b cubed, and that's going to have an extra bracket on it. So let's take a plus b, we're going to cube it, and so that means we're going to have 3 lots of brackets. So we have to multiply all of these by each other. Now we've actually already, with the previous bit, multiply together the first 2 brackets. So what we can do here is, I'm just going to rub out 2 of the brackets, because we already know what 2 of these brackets multiplied together is. It's 1a squared plus 2ab plus b squared. So all we have to do to get the next one is to multiply all by a and multiply all by b. So we multiply the whole thing by a, we're going to get a cubed plus 2a squared b plus ab squared. If we multiply all by b, then we're going to get ba squared, we're going to get 2ab squared, and we're going to get b cubed. So we collect all the like terms together. Altogether, that will give us 1 lot of a cubed plus, and now a squared b and ba squared are the same thing. The letters are in a different order. That doesn't matter. Altogether, that'll be 3 lots of a squared b and 3 lots of a b squared and 1 lot of b cubed. So when we're talking about binomials, we're talking about expanding brackets, particularly brackets that have the same value. So let's write these answers under each other and see what we can see. The next thing we're going to look at is, we've got 2 lots of the brackets and 3 lots of the brackets. What if we only had 1 lot of the brackets? Well, if it was only to the power of 1, we've only got 1 set of brackets, and so there's nothing else to multiply it by. So we'd be left with a plus b. And I'm going to write it the same way, so we'll write it as 1a plus 1b. Okay, so that's the bracket to the power of 1. What happens if we had it to the power of 0? And it's a little bit weird and abstract, to the power of 0, because we're not going to have any a's or b's to multiply by each other. So is this going to be 0 then? Well, if you think about laws of indices, anything to the power of 0 is 1. So we need to write 1. And can you see that these answers are forming something like a little triangle? Now, moving on to the next one, what if we wanted a plus b to the power of 4? So we need to do some working out for this. So we want a plus b to the 4. That means I've got 4 lots of the brackets with a plus b in each. And we already know what 3 of these brackets multiplied together is. It's the 1a cubed plus 3a squared b plus 3ab squared plus b cubed. All we have to do is multiply that through by a and multiply it through by b. Let's multiply it through by a first. So a cubed times a would be a to the power of 4. 3a squared b, so we're just making the power on the a go up, and the same for the next one. And then with b cubed, that's going to have an a on it as well. So we multiplied through by a. Next, let's multiply through by b. So the first one, we're going to have a cubed times b, which should be a cubed b. Don't think we have one of those. Then I'm going to multiply 3a squared b by b. So that'll increase the power of the b. That'll be 3a squared b squared. Multiplying 3ab squared, again, that'll increase the power. So it'll be 3ab cubed. And then b to the power of 3 times b will be b to the power of 4. And we can write in our final answer. So firstly, we've got the a cubed. So that'll be 1a cubed. So I'll cross that one out because I've written it down. Then we're going to have the 3a cubed b and the 1a cubed b. Altogether, that'll be 4a cubed b. Then we're going to add together the a squared b squared. So it's 3 and another 3. That'll be 6 altogether. Then the ab cubed and the 3ab cubed is 4ab cubed altogether. Then the final one, we've got a b to the power of 4. So that'll be 1b to the power of 4. Now, hopefully what you're seeing here is that we have a pattern in this triangle. And there's a name for this. And we call it Pascal's triangle, because it was Pascal who discovered it. Now, the point of this is you don't need to multiply out the brackets, especially with the complicated numbers we see in our question. We've got a third in there. Multiplying a third by a third, we get some big fractions there. We don't want to do that manually. We want to use a pattern to speed it up. Now, we've got 1 to the power 4 here, and our question to the power 4, so we could stop here. But we're just going to have a look at how we'd use a pattern to find the power 5 and the power 6, because we might need those for future questions. So I'm just rubbing out my working out. Let's write down what we're trying to find. A plus b power 5 and a plus b to the power 6. Okay, so when you have a look at the pattern, you'll notice going all the way down the left-hand side, we have 1a squared, 1a cubed, 1a to the power 4. So we must have 1a to the power 5 and 1a to the power 6. That's going to be the same on the right-hand side. We have 1b, 1b squared, 1b cubed, 1b to the power 4. So we must have 1b to the power 5 and 1b to the power of 6. Now, what about in between these? The first thing to do is look at the powers. From left to right, we start off with the big powers of a on the left, and then we end up with the big powers of b on the right. Now, if you look at every single one of these, the powers of a go down from left to right. So starting at the top, we've got a squared a cubed a squared a to the power 4, a cubed a squared a. So going in the other direction, we must have a to the power 4, a to the power 3, a to the power 2, and then a to the power of 1, going from left to right. Same underneath, start with a to the power 6, so it must be a to the power 5 and 4 and 3, a to the power 2, and a to the power 1. Now the b's work in the opposite direction from right to left, they're going down. So we start with b to the power 5, we will then have b to the power 4, b to the power 3, b to the power 2, and b to the power 1. And below it, we start with b to the power 6, so we'd have b to the power 5, b to the power 4, b to the power 3, b to the power 2, and b to the power 1. So that's the powers and the letters sorted out. Now, what about the numbers? How do they work? Now, if you look really carefully at the numbers, we know we have 1 at the left and right side, but the numbers change in the middle. Now, if we have a look at the middle section, we can see 3 rows down, we've got a 2. Below it, we've got a 3, then a 4. So we must have a 5, then a 6. And the same on the right side, you can see there's a little kind of diagonal line. We have 2ab, 3ab squared, 4ab3. So it must be then 5ab, the power 4, and then it must be 6. So we can see some patterns there. Now, what about the ones in the middle? Well, the secret with the numbers is it's the 2 numbers above it added together. So when we look at right in the middle, we've got the 6a squared b squared. Above it, to the left and right, we've got a 3 and a 3, and that's where the 6 comes from. So for the empty ones below it, when we have a cubed b squared, above it there's a 4 and a 6, so that's going to add together to give us 10. The one next to it also has a 4 and a 6 above it to the left and right. That's also going to be a 10. So now we've completed the a plus b to the power of 5 row. Now the row below it, we've got some empty gaps there. So the first one, a to the power 4, b to the power 2. There's a 5 and a 10 above it. There's a 5 above it to the left, and a 10 above it to the right. 5 plus 10 is 15. On the other side is going to be 15 as well. And right in the middle, the a cubed b cubed, there's a 10 and a 10 above it. So that's going to be 20. So that's how you find Pascal's triangle and the patterns within it. So now we have the triangle. How do we solve the question? A third minus x all to the power of 4. Well, the method is we're going to pretend that it's going to be an a plus b to the power of 4. If it's a plus b to the power of 4, that means that in the position of a, we have a third, and in the position of b, we've got negative x. And what we're going to do is we're going to substitute a being a third and b being negative x into the power 4 row of Pascal's triangle. So let's write that row down. So it's going to be 1a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the power of 4. So if we substitute this, we're going to swap all the a's for a third. So we're going to have one lot of a third to the power of 4. I'm just going to put the substituted numbers in brackets. Then we're going to have 4 lots of a third cubed multiplied by b, which is negative x. Now, rather than write a multiplication sign there, I'm just put a little dot. The little dot is another way to show that it's a multiplication. Then we're going to have 6 lots of a, which is being squared, and we're going to multiply it by 2 lots of negative x. So I'll put in brackets this time, 2 lots of negative x. Then we have the 4 multiplied by a, which is a third, multiplied by b cubed, which is negative x cubed. And then we're going to add on 1 lot of b cubed. So b is negative x. And sorry, it's not cubed, it's the power of 4. So all we need to do now to answer our question is to work through each term and work out what it all is. So our first term is a third to the power of 4. So you could do that in your calculator. So I put a third in brackets. So you can do 1 divided by 3, or you could use the fraction key on your calculator, if your calculator has one, and then raise that to the power of 4. Now, I'm getting quite an awful looking decimal on my calculator. Now, you might have an SD button on your calculator, and that will turn it into a fraction for you. Alternatively, you can think about doing this as a fraction question. And it's going to be a third times a third times a third times a third. And when you multiply fractions, you multiply the numerators and the denominators. So you're essentially doing 3 to the power of 4 for the denominator, and that's 81. So in your final answer, it's going to start off with a 1 over 81. Moving on to the next one. Now, use BIDMAS for this, and the third is being cubed. So you think about 3 cubed being 27. That's going to be a 1 over 27. Be multiplied by the 4. So it's going to be 4 over 27. And it's been multiplied by negative x. So I'm going to pop the x on the end. Because it's a negative x, it's not going to be a plus that, it's going to be a takeaway that. Moving on to the next one. This time the third is to the power of 2. So 3 to the power of 2 is 9. This will be a 9. But it's been multiplied by 6. So it's going to be 6 over 9. And actually, we can simplify that. 6 over 9. We can divide the top and bottom by 3. So that's going to be 2/3. It'll be 2/3. And the x is being squared. Now it's a negative x squared. X times x is x squared. And negative times negative is a positive. So we can leave it as a plus. For the next one, the third's not been raised to any kind of power, but it is being multiplied by 4. So we can write it as 4 over 3. X is going to be cubed, but it's a negative x cubed. Now, 2 negatives will cancel it to make a positive, but the third will make it negative again. So we're actually taking away there. Then for the final one, negative x to the power of 4, we're adding on x to the power of 4. I'm going to have 2 sets of double negatives, so it will stay a positive. So what's our final answer? Our final answer is 1 over 81, take away 4 over 27x plus 2/3 x squared, take away 4 over 3 x cubed plus x to the power of 4. And that is our final answer. So moving on to another example, we have 1 plus 6x, and it's all to the power of 4. So what we're going to do is consider that this could be a plus b to the power of 4. A would be 1, and b would be 6x. So what we need to do is find the relevant line of Pascal's triangle. And that relevant line, it's going to be the power 4 line, which I'm going to highlight. This is what we're going to be using. And what we're going to do is go through this one step at a time, swapping all the a's for 1 and all the b's for 6x. And when I write this out, what I am going to do here is I am going to put brackets around the a's and the b's, which will make it easier to do. So starting off with 1 lot of a to the power of 4. So I'm going to write down a to the power of 4, and a is 1. So that's a to the power of 4. We're going to add on to that 4 lots of a cubed and then b. So a is in brackets the 1, b is in brackets 6x. Then we're going to have 6 lots of a squared and b squared. So 6x is going to be squared. Then 4 lots of a and then b cubed. And then finally, the b is going to be to the power of 4, so that's 6x to the power of 4. So we've got 1, 2, 3, 4, 5 terms there. So now we've done the substitution, again with the a's and b's in brackets. Now we can work through these. Now we have to follow BIDMAS to do the cubing, squaring the powers first. Our first one is 1 to the power of 4, and anything that's a 1 to the power of something is going to give us 1. Moving on to the next one. 1 cubed is 1. And it's being multiplied by the 4, which will give us 4, and it's being multiplied by the 6. So 4 times 6 is going to give us 24. And then we have the x. Go to the next one. Doing the squaring first. 1 squared is 1, and 6 squared is 36. So we've got 36 times 1 times 6. Now the 36 times 6 is going to be 216. So that's a 6 squared from the 6x bracket, a 1 squared from the 1 squared bracket. Altogether that's 36. Then multiply it by the 6 on the outside, 216. Then the x, that's being put to the power of 2. The tricky bit here is the 6x bracket, and it's the 6 is being squared, but also the x is being squared. Both parts are being squared. Moving on to the next part. So we've got a 1 and a 4. That's going to make 4. We need to do the cubing first. So 6 cubed is going to be 216 again. We're going to times it by the 1 and times it by the 4. Altogether, that's going to give us 864. And the x is also being cubed. That's x to the power of 3. So again, we've done 6 cubed times 1 times 4. For the last one, we have 6x all to the power of 4. So we need to do 6 to the power of 4, which is 1,296. The x is to the power of 4. The 6 is to the power of 4 as well. So they're both to the power of 4. So we need to write the x to the power of 4 there as well. And so the answer in pink is our final answer. So we have 1 plus 24x plus 216x squared plus 864x cubed plus 1,296 x to the power of 4. Moving on to question 3. So we have 7 minus 2x, and it's all to the power of 5. So again, we're going to treat this as if it's a plus b to the power of 5. And a would be the 7, and b would be the negative 2x. So we find the relevant row of Pascal's triangle. It's the power 5 row. Let's highlight it. This is what we're going to be substituting into. And then what we're going to do is we're going to write this out, but every time we come across an A, we're going to put a 7 in brackets, and every time we come across a B, we're going to put minus 2x in brackets. So we're starting off with A to the power of 5. So I'm not going to write A, I'm going to write 7. So it's 7 to the power of 5. Then we're going to add on 5 lots of A, and that's the power of 4, and B, there's only one B, that's negative 2x. Then we're going to add on 10 lots of A. A was 7, and it's cubed, and then B, where B is a negative 2x, and that's squared. Then we're going to add on another 10, and that's 10 lots of A squared and B cubed. Then we're going to add on 5 lots of A. There's only one of those, there's no power, and B to the power of 4. So negative 2x to the power of 4. And then the last bit is we have B to the power of 5. So B is going to be negative 2x, and that's the power of 5. So now we need to go through each term to work out our final answer. So we'll start off with 7 to the power of 5. This should be quite a large number. 7 to the power of 5 is 1,000 or 16,807. Moving on to the next one. Now do the powers first. We have 7 to the power of 4, so it's a little bit shorter. It's 2,401. We've got to multiply that number by the 5 and by the negative 2. Altogether, that's going to give us negative 24,010. And then we have the x as well. Moving on again. So again, do the brackets first with the powers. So we have 7 to the power of 3, which is 343. Then we're multiplying that by, we've got the negative 2 squared, which we multiply by 4. And we've got the 10 on the outside as well. So altogether, that's going to be, it's going to be positive, because a negative times negative is a positive. So it's going to be 13,720. And the x term was squared. Moving on again looking at the powers first. So we have 7 to the power of 2 is 49, and we have negative 2 to the power of 3, which should give us negative 8. So it's negative 8 times the 49 and then times the 10 on the outside. Altogether, that is, now it's negative, so let's make sure we've got a negative symbol there, 3,920, and the x was cubed. Moving on again. So again, we've got the negative 2 to the power of 4, which should give us 16, times by the 7 and times by the 5. Altogether, that is, it's a positive 560, and the x term was to the power of 4. And then for the last term, we have negative 2 to the power of 5, and that's going to give us negative 32. And the x was to the power of 5. So our final answer is 16,807. Take away 24,010x plus 13,720x squared. Take away 3,920x cubed plus 560x to the power of 4, take away 32x to the power of 5. And so that row in pink, the entire pink row, that is our final answer. Now, moving on to a new example. The last two examples took about 5 minutes, but they only took 5 minutes because we already had Pascal's triangle written out for us. And in the first question, it actually took 12 minutes to go through all the patterns within it to write out Pascal's triangle. Now, when you get confident, you can sketch it in less time, but there is a shortcut. There is a way to find any of the coefficients in the triangle. Now, by coefficient, what I mean is the numbers, and it's the numbers before the letters. So I'm just highlighting in green all of the coefficients. So I'm just talking about the whole numbers. I'm not talking about the letters or the powers. So you see, they always have ones on the left and the right. Then in the middle, we have various numbers contained. We talked about how we got those numbers because each number is the two numbers above it added together. That's the number above to the left and the number above to the right. So your calculator can give you all of these numbers. How does it do it? Well, if you have a look at where this is written in the question, 7C4, that's a clue. And if you look at your calculator, you're looking for that C button. Now, the way the button normally looks is NCR. So this is a button on your calculator. It's going to represent the C. So all I need to do is press 7NCR4 to get the answer to this question. And 7C4, the answer to that is 35. But what does it mean? So with the NCR, you've got an N before the C and an R afterwards. So what do these mean? So let's look at the N first. The N is the number of the row. So we have a look at the brackets at the side. We have row 0, we have row 1, row 2, row 3, row 4, row 5, and row 6. So you have to say which row it is. So in our question, we're starting off with a 7. This is talking about row 7, which we don't have written out. So let's write that down. N is the power of the row. And again, that's represented by how we're writing out the A plus B brackets. Now, next, we're going to have a look at the R. Now, with R is the position in the row. And what we do is always start off with 0 for this. So the first number on a row is position 0. So on the second row, we've got position 0 and position 1. On the next row down, we've got position 0, position 1, and position 2. So again, the 1 on the left is 0, and you go across 1, 2, 3. And for each one, you'll notice that the number goes up by 1 each time. And R cannot be greater than N. Otherwise, you get an error on your calculator. So again, in purple, to write a little index of all of the positions. And test it out on your calculator. So I'm just going to circle one. So let's say we want to find a random thing here. So I'm going to circle one. Let's choose this one in the middle. Okay, so it's a 6. So we need to get 6 out of our calculator for this. Now, N is the power of the row, and that is on row 4. If you look to the right, you'll see it's A plus B to the power of 4. So we write in 4. Then we press the NCR button, and then it's position 2. Click 2, press equals, and I'm getting 6 out as an answer. So you should have written 4 NCR 2, and that gives 6. So now you can go directly to the coefficient without writing out the entire Pascal's triangle. There's also one other detail to look at. Now, if you look at all the numbers that I've written in purple, we're kind of indexing the position in the row. Have a look at the power on the B, and you can see it's the same as the power on the B. So as well as having the position in the row, it's also the power of B. So let's have a look at the next question and how we're going to use this. So we have a question, 9 plus x, all to the power of 7. And to start off, it looks like one of those easy questions that we did. So we would say that this is going to be a plus b, the power of 7, with a being 9 and b being the positive x. Now we could write out the entire expansion for that, and we could use either a sketch of Pascal's triangle that we draw, like we did with the easy questions, or we could use the NCR function to work out each term one by one. So you would do 7C0, 7C1, 7C2, just generate all of them. But you'll notice the question has an extra step to it, and it says it only wants the term that is x to the power of 4. So out of all the 8 terms you'll get out of this, it only wants the x to the power of 4 term. So we can use NCR to do this for us. So with NCR, we want n and we want r. Now the n is going to be the power on this, and the power is power 7. So the n is going to be replaced with a 7. Then we want the r. Now the r, you'll remember, it was the position in the row. And we don't know what position in the row it is, but it says a term in x to the power of 4. And you'll remember that the power on b was the same as the position in the row. Now, since b is x, then x to the power of 4 means that the x will be raised to the power of 4. That means that the row position will be 4. So on the calculator, you're going to press 7 NCR 4, and that will get you the coefficient on the x to the power of 4. Let's type it in, 7 NCR 4, and I'm getting 35. So now we have the coefficient of the row. We have to think about how this worked in Pascal's triangle. We did our substitution. So for each row, we'd have the coefficient at the start. So our coefficient is 35. That was multiplied by the a term, which is 9 for us, and then it was multiplied by the b term, which is x for us. Now these had powers on, didn't they? Now we know that since the position in the row is 4, that the b has power 4. Another thing to think about is the powers in all the rows in Pascal triangle always added up to something. Now for this one, since it's 9 plus x all to the power of 7, the powers are going to add up to 7. So the 9 must be to the power 3 for this to add up to power 7. And now we've recreated what the substitution would be, and we've done that without doing the other 7 terms to be part of the substitution. We can work out just this one term. So like we did before, do 9 to the power of 3, do the powers first. That's 729, and then we're going to multiply it by 35. And that is going to give us our answer, which is 25,515. And then remember, the x is the power of 4. So then that's 25,515 x to the power 4. So let's recap what we did. So we know that the coefficient is going to be on row 7 because the brackets are the power of 7. We know it's position 4 because the b term is to the power of 4. X is to the power of 4. So we know the 35 is going to be part of our substitution. We know that the b term is going to be to the power of 4. All that's left is realising the a term is to the power of 3 because the powers always added up to 7. If you think about how it went through, you know you'd have a to the 7, then a to the 6b, a to the 5b squared. The a's always went down and the b's went up. So they kind of compensated for each other. So we'd always be adding up to that power, in this case, power 7. So moving on to another example, we have 5 over 3 plus x all to the power of 7. So we're going to have our a plus b power of 7. A has been swapped for 5/3 and b has been swapped for x. We want to know the coefficient on this term. So the first thing we have NCR. The n corresponds to the power, and it's power 7 for this. And the r corresponds to the position in the row. Now we know that the b power is always the same as position in the row. B is x, and x is the power of 3. So if x is to the power of 3, that means that r is 3. So on your calculator, press 7 NCR 3, and that's giving me 35. Then we need to think about what these substitutions are going to look like for this. So it's always the coefficient, which we know is 35. There was a bracket for A. There was a bracket for B. We know that B is the power of 3 already, and then the powers have to add up to the power 7. So the 5/3 is going to be power 4. So for the BIDMAS rules, do the powers first. So we're going to do 5 over 3 to the power of 4. And I'm getting a decimal for this. And you probably want to avoid decimals. You might have a SD button on your calculator. It'll change that decimal into a fraction for you. Another thing to think about is that 5 to the power of 5 over 3 to the power of 4, it's going to be 5 over 3 times by itself. It's going to be 4 of them multiplied by itself. That's going to mean it's going to be 5 to the power of 4 over 3 to the power of 4. So what we can do is we can try and leave it as a fraction, which might mean that our answer is a little bit easier to read. So 5 to the power of 4 is 625. 3 to the power of 4 is 81. And we need to multiply that by the 35. So 35 times the numerator, 625, is going to give me 21,875. And that is going to be all over the 81. And then the x is being cubed, so it'll be x to the power of 3. Now, if you want to try and simplify that fraction, you're welcome to. I don't think this fraction simplifies. It's quite a horrible fraction. So we can leave it like that, and we should be getting full marks, hopefully. Maybe the question might say simplify it. It might say change it to a mixed number, and you can do those things. So you could divide through the 21,000 number by 81. Maybe use short division or long division to do that. But I've shown you how to use a binomial part of this question. So any kind of fraction simplification is perhaps part of another topic that we can come back to. Now moving on to the hard questions. We're going to get binomial expansions of powers so large it'll take quite a long time to work it out. So for example, this one is 1 plus x and it's all to the power of 10. Now altogether that would be 11 terms to have to work out. So it's shortened the question by saying only find the first 3 terms. So what do we do? Well, it's the same as the medium questions, we just do it 3 times. So we say that this would be a plus b, the power of 10, and a is 1, and b is x. We want to find the first 3 terms, and we use NCR 3 times for the 3 coefficients. Now the n is the power that we're using, and it's power 10. All the n's are going to be 10. The r's is the position in the row, and it's the first 3 terms. So it's going to be position 0, 1, and 2. And you have to remember that the first position, it's always position 0. You start with a 0 with these. So I'm going to type in 10 NCR 0, 10 NCR 1, and 10 NCR 2. Now, we should know that 10 NCR 0 should give us 1, because 1's always the first term, and it's 1. Then we can do 10 NCR 1, which is 10. And then we can do 10 NCR 2, which is 45. So they are our coefficients. Then you've got to think about how the substitution works. So you have the coefficient first, then you have the a term, which is 1 for us, and then you have the b term, which is x for us. Now, with the powers, we start off with the a being the highest possible power. So given this is the power of 10, the highest possible power is going to be a 10 for a. And then the a and the b add together to make that power, so the b must be power 0. For the next term, we have the coefficient of 10 that we worked out. Then we have substitutions for a and b. Now remember, the a powers go down, so going down from 10 will be 9, and the b powers go up, so going up from 0 will be 1. Again, 9 and 1 add up to 10. And for the third term, we'll have 45. Our substitutions for a and b. So the a powers going down, it'll go down to 8, and the b powers going up, it'll go up to 2. So now what we need to do is to work these out. So look at the powers first. We have 1 to the power of 10. Well, 1 to the power of anything is 1, and we are timesing it by 1. So that will give us 1. Now with the x to the power of 0, anything to the power of 0 is 1. So the x is going to go away. It's going to be a 1. And 1 times 1 times 1 is 1. So we're done there. For the next term, 1 to the power of 9. Again, anything to the power with a 1 is going to be a 1. We do 1 times 10, which is 10. And then with the x is this time to the power of 1. So we can write 10x as our answer. Then for the next one, again, 1 to the power of 8. Any power with a 1 is going to be a 1. So we have 1 times 45 is 45. And the x is the power of 2. So our final answer is 1 plus 10x plus 45x squared. They're the first 3 terms of the binomial expansion for 1 plus x all to the power of 10. And again, this would have 11 different terms. We've just got the first 3, but we've only been asked for the first 3. Next, we want the last 2 terms of a half minus x all to the power of 8. So, as usual, it's going to be a plus b to the power of 8. A is a half, and b is negative x. So make sure that any negative is with a symbol after it. So don't just leave it in. It's not going to be a positive x for b, it's going to be a negative x. We're going to be using NCR for the last two terms. N is going to be the power of the row, so it's power 8. So N is going to be 8. The R is going to be the position in the row, and it's the last two terms. So the last term is going to be 8, and the one before it is going to be 7. So we're going to do 8 NCR 7, which is giving me 8. And we're going to do 8 NCR 8, which is going to give me 1. Remember, the first and last term should always be 1, shouldn't it, with the way that the Pascal's triangle works. Now we're going to think about our substitutions. So we always have our coefficient first, which is the 8. Then we have our substitution for A and our substitution for B. We'll think about the powers for this in a moment. Let's move on to the next one. We need the coefficient 1, the substitution for A, and the substitution for B. And then we can think about the powers. Now, right at the end, that's when the B power is at the biggest. And we are on power 8 here. So B is going to be power 8, and A will be power 0. Now we know as we work our way to the left, the B's are going to go down. So we'll go down to a 7 for the next one. And the A's go up, so it'll go up to a 1. Remember, the powers have to add up to the total. So we've got 1 plus 8, or rather, we've got 1 plus 7 is 8, and we've got 0 plus 8 is 8. So the powers add up to 8. Now we just need to work these out. So we've got a half to the power of 1. Well, anything to the power of 1 is going to stay the same. So we've got a half. And we're going to multiply it by 8. That is going to give us 4. Then the negative x is to the power of 7. So we know that we have x to the power of 7. What about that negative? Well, if it's an even power, all the negatives will cancel out. A double negative is a positive. If it's an odd power, it's going to stay negative. So it should be negative 4x to the power of 7. For the next one, the half is to the power of 0. Anything to the power of 0 is 1, so we're effectively ignoring the a term. And it's being multiplied by 1. Again, that's going to give us 1. And then the negative x is to the power of 8. So it's going to be 1x to the power of 8. And it's an even power, so all those negatives are going to pair up with another 1 to cancel out. So it's going to be a positive x to the power of 8. So our final answer is negative 4x to the power of 7 plus x to the power of 8. Again, they're the final two terms of the 9 terms this expansion would give us. Looking at our last example, so we have 1 minus 4x all to the power of 7. So we can write it as a plus b to the power of 7, with the a being 1 and the b being negative 4x. Again, make sure that negative is included with the b term. We need to find the coefficients of the last 3 terms. So we're going to use NCR 3 times. Give us the 3 coefficients we need. The n is the power we're looking at, and it's power 7. So it's going to be row 7 of Pascal's triangle. The r, well, we want the last 3 terms. The last term would be 7. 7 is the last term on row 7. And the terms before it would be 6 and 5. So we have 7C5, 7C6, and 7C7. So check it on a calculator. 7 NCR 5 gives you 21. 7 NCR 6 gives you 7. And 7 NCR 7, we should know already that's going to be 1 because it's the last row. The first and last rows are always 1. So now let's think about our substitution. We would have the coefficient, we would have the substitution for A, and the substitution for B. We'll think about the powers at the end. Moving on to the next one, we have the coefficient, the substitution for A, and the substitution for B. For the last one, we have the coefficient, the substitution for 1, and the substitution for B. Now we'll think about the powers. Now, at the end, B is always the largest power possible. So with this one, it's row 7, it's power 7, so this will be a power 7. For the B's, we'll go with 7, 6, 5. Now, the A and B have to add up to the 7, so it's going to give us 0, 1, and 2. So 2 plus 5 is 7, 1 plus 6 is 7, and 0 plus 7 is 7. So that's our substitution done. Now let's work out the numbers. Do the powers first. So we have a negative 4 to the power of 5 in the first bracket. And negative 4 to the power of 5 is negative 1024. That's been multiplied by the 1 squared. Well, that'll be 1. And it's been multiplied by the 21. Altogether, that should give you negative 21,504, and the x was to the power of 5. Moving on to the second term. This time we've got a negative 4, and that's the power of 6. Altogether, that's going to give us a positive 4,096. That's been multiplied by 1 to the power of 1, which is 1, and it's been multiplied by the coefficient 7. Altogether, that is a positive 28,600. and the x was to the power of 6. Now, for the final one, we have negative 4 to the power of 7. That's giving me negative 16,384. Now, I've written that down because it's getting multiplied by 1 to the power of 0, which is 1, and it's been multiplied by a 1. So you multiply by 1 twice, it's not going to change, is it? And then the x was to the power of 7. So the final answer is negative 21,504 x to the power of 5 plus 28,672 x to the power of 6, take away 16,384 x to the power of 7. And that's the final answer.